Okay, welcome everyone. Covering another couple chapters in the SQL book that we've been working through. So this one we're doing chapters 20 and 21. So it's going to be transactions and cursors. So we'll just get into it. So the first piece of this is what are transactions. So I think that we've actually kind of mentioned these in the past a little bit. But just to go into what exactly they are, sometimes when you're doing various write operations, you want guarantees that everything happened that you expected in a certain sequence. If you do things out of order, or if you do things incompletely, then you can end up in bad states with your database. So transactions are kind of this tool that helps you do batches of operations all together and guarantee that they all happen the way that you would expect. So just pointing out partial completion of these can put your database in a wonky state. So I'll give some more examples of that on later slides. So just an example of what you might use a transaction for. So in the book, they gave us this example of adding an order to a database. So you start this process where you check if a customer is in the database. If not, add them. So you add their customer ID, then you retrieve their customer ID, and then you add a row to the order. So now you have this new customer or an existing customer, and you add an order to the orders table. And then you have to go get that ID back. And then after that, that order probably consists with a few different items. So you might have apples, bananas, carrots, whatever. So several things get added to your order items table. And so you have to add all of those. And then you associate that back to the order. So you have a customer, they've got an order, and then that order will contain potentially multiple different items. And so you want to have that entire chain to happen. And so this part at the end is explaining the various ways that that can go wrong, and you can get in this sort of corrupted state of your database. So depending on where it fails, something weird can happen. So for example, you could have it end right at the after it retrieves the order ID, or after it adds the order ID. And so what happens there is now you have an order ID that is not associated with any item. So you just have a blank order. And that might be okay, but you don't probably want that. You probably want those items guaranteed to be associated with that order. And so you want to make sure that that final step happens. But even worse than that, you can end up with a partial order. So if you completed this step, you add the order ID to the orders table, and then you go to the order items and you start adding that apple, banana, carrot, whatever grocery list of things, and it fails partway through, you can end up with this order ID that was supposed to have all of these items in it, and it only has some of them. And so that can be problematic, and you have no way of detecting that. So the other failure case, you have you know that you can't have a blank order, so you can kind of look at that in the database and you can say this is just wrong. But the second case with the partial, you have no idea that there was stuff that it was missing. You look at the database and there's 3 items out of 5, but you don't know the 2 that it was missing. So it just looks like something completely valid, but you don't actually realize that it failed. So that was kind of the example of what a transaction, what you would want to fix with a transaction. So how does it actually do that? So I'll start by defining some various different terms. So the transactions, like the actual statement of a transaction, is a block of SQL. So you say, like, in between these two is all of the SQL that you want to do the transaction. And then you want to set various different so I'll start with the rollback, actually. The rollback is where you want to undo certain things. So you don't want to complete you can leave something sort of in limbo, and then instead of just leaving it in that decayed state, you roll back and you say go back to a good point where you don't have that messed up data in your database. And so committing is actually finalizing the write to the database, and then the save point is kind of like, here's the various breakpoints where you want to return back to. So you say, okay, we want a save point here, and then if something goes wrong, go back to that save point. So you roll back to the save point. And one of the things they were mentioning is you can roll back, insert, update, and drop and delete, but you can't undo, select, create, or drop. So select, you don't really have any reason to want to roll that back because it's just a read. You're not actually changing anything in the state of the database. And then create or drop are just not reversible. So you can have those inside of your transactions, but once they occur, they're not reversible. If you create a table, if you drop a table, that's just done. So the inserts, updates, and deletes will be rolled back, but the creates and the drops are just permanent. So some actual code examples of these statements. So this top left one, they're showing you can begin a transaction, you can do various operations, and then when it's doing this, it's not actually permanently writing anything. It's just basically saying, here is what we need to do. And then it actually does the finalized operation when you commit the transaction. So if it fails somewhere here, it won't actually do these operations. And so if you want to intentionally roll something back, this is what it looks like. So you can say delete from orders and then roll that back. So it won't actually do that, basically. And then here's kind of piecing that together with the transactions, the save points, the rollback, and then finally committing. So you begin your transaction, you do various operations, you can insert some values, and then you say, make a save point. So you say, this is the start of the order. And then you do some more operations, you insert some more data, and then in this statement, you can basically say, if this didn't complete correctly, go back to start order. So at this state, before you did this insert, and then you won't end up in this messed up state where you have these additional pieces of inserted data that aren't correct. And so basically you're giving it a bunch of breakpoints and where to go back to. With this original start order, they're doing it a few times where you're saying, okay, if this went wrong, go back to start order. If this went wrong, go back to start order. If this went wrong, go back to start order. But if this is all completed correctly, then commit the transaction and actually write that to the database. So if it fails anywhere along here, it's just going to revert back to the start order. It's not actually going to complete or partially complete any of these steps.
Hey, Ryan.
Yeah.
Yeah, if I could just jump in real quickly. So we haven't talked about the if statement in SQL. I don't know that like SQLite, some of the smaller systems, but the big systems like Microsoft, Oracle, they support this. And if you've seen an if in any other language, it just works the same way, right? So in this case, it's using this special variable at error, which the database system manages. And so if there is an error in the previous statement, then that variable will have the error number. It'll be non-zero. And so that's if you're just at all tripped up by that. Again, I don't think this is super critical for data science workflows, but it's probably useful just to understand as a concept. There's a word that people throw around, so just that you've heard it, people talk about atomic operations. And so having this idea of a transaction means that you can have multiple SQL commands, in this case, multiple inserts or whatever, and you could treat it as one atomic operation where either nothing will happen or the whole thing will happen the way you want it to. And so that's the purpose of this. And so, you know, the classic example is you're transferring money from one bank account to another. It says take your current balance in account one and minus 100 to it. And then it's going to do plus 100 to the second account. You never want it to fail halfway through where it took away 100 from your first account, but didn't give you 100 in the other one. That would be really bad. So it would kind of be annoying if you wanted to do this transfer $100 and it didn't happen, but that's, you know, a pretty minor annoyance compared to you just lost $100 and it's just gone. You know, as Ryan was saying, you can't even necessarily tell if anything bad happened. It just subtracted 100 and then, you know, something happened and it stopped. So useful to know that there is this that you can create atomicity where you know, an individual statement may be atomic where it either works or it doesn't work, but now you can extend that to multiple things that you write.
Yeah. Now you can do a series as a single unit. Yeah, you figured it out, Sule. So just to make that more explicit, throughout all of this, I tried to pick the Microsoft SQL Server examples because that's what I'm most familiar with. I was a little bit frustrated with that because throughout there's various examples in different variants, but they didn't have the full thing in all of the different versions. So it would start in Microsoft and then it would just throw in random Oracle. And I had to kind of look at the differences in syntax and piece together what was happening. So I will try to use the Microsoft SQL Server variants where they were available, but there were certain examples that were only in Oracle. So I'll point out when they're Oracle, but assume that the rest is Microsoft SQL. So that was everything on transactions. It was a fairly quick chapter, and then we'll get into cursors now. We can pause for a second. Any other questions on transactions other than Ted's comment?
Yeah, for transactions, so do they recommend using that rollback and commit, just doing your coding that way whenever you're doing an insert or an update or a delete statement?
I think it depends on the data that you're interacting with and what kind of series of commands you're doing. If you're just working, it depends on the scenario, because you might just have a small personal database that you're working on something with, and you can kind of, if you're interacting with it kind of manually, it's one thing, but if you're doing it in like a large scale application where there's all kinds of different concurrent interactions going on, you probably care more about the state always being good. I don't know if you have any comments on that, Ted.
Yeah, like when I first started doing SQL, I was working for a pretty small company, and we didn't have like separate sets of production servers and development servers and whatever. So there were times when I was running commands right on the production system, right? And so it was an education company. And so like if I'm deleting a course, like I'm going to be really paranoid that I don't want to delete the wrong thing. So absolutely, as a best practice, I would begin a transaction. This is, I think, the trick that Sule showed a few weeks ago. I would do the delete, and then I would run a select to see what things looked like after the delete happened, to make sure that it deleted the one I wanted and only the one I wanted. And then when I was fairly comfortable that everything was okay, then I would run the commit transaction and it would be permanently written. And if I was unsure at all, I could just do a rollback and I could do a little bit more digging. Because even if it was okay, rolling back just means that, you know, I'm spending longer getting it done, but it doesn't like hurt anything. And so, yeah, so like for beginners, I think that's a good way to learn. Again, not so pertinent for data scientists. I really expect that you're mostly just going to be writing selects only, you know. But But I think it's good just to know that this is a structure that exists, and it's fairly important in real production code. You know, when your bank is writing stuff to the database because, like, you know, you transferred money, things like that, you're expecting that they're using these kinds of more sophisticated things to make sure that everything that's supposed to be one big thing happens as one big thing.
I think that they're a good security measure, but it also doesn't care that it doesn't guarantee that you're doing what you want. So the trick that Ted was explaining is good for inspecting before you actually commit some final changes. But if you do something wrong, like if you just say delete this row and it wasn't the row that you wanted, it being wrapped in a transaction isn't going to change that. It's still going to complete the incorrect. So it gives you guarantees, but it doesn't guarantee that you're doing the right thing. You still have to kind of be cautious with anything that you're doing with the database.
Yes.
So as long as you don't commit whatever you're doing, then and you just double check that what you did was right, then that is just as good as doing something wrong and having that rollback there.
Yeah. Now I mentioned briefly that we haven't talked about, and we're not going to talk about how databases do what they're doing or whatever. But the short version is when you open a transaction and you start modifying like the list of courses, then it means that other people can't actually do anything with the list of courses. They can't read it, they can't update it, they can't do anything else. And so you don't want to like have a production system and just leave a begin transaction open for a super long time, right? So normally what I would do if I were doing this is I would write the begin and the delete. I would already have written the select that I was planning to run to check to see what got deleted, right? I would do a select before, and then I would do the delete, do the select after to compare the two to see like there should be one fewer course, the row count should be one less, and you know which one got deleted or whatever. And then if it didn't look right, I would immediately run the rollback and try and figure it out. And if it looked good, then I would run the commit. But during the time that I did that, if it was, let's say, 45 seconds, everyone else would be frozen and their queries wouldn't run. So I would tend to do this kind of thing like, you know, late at night as opposed to in the middle of the day. I would say that following software engineering best practices and having a development server and testing all your code there and then releasing that to production is a far better way than this, but it is something that, you know, people do use just to be able to inspect their stuff before they finalize it.
So the rollback affects the entire table and locks out any other queries to the table at the time that the rollback's occurring. Is that correct?
No, it's not the rollback. It's actually the transaction itself. So when you say begin transaction and then you modify something, I'm not going to go into all the guts of it, but then whatever it is that you modified, nobody else can touch it until you either finish it or undo it by rolling back. So basically what happens is SQL Server is going to say, oh, Richard's modifying the courses table. I'm locking it. Only Richard can use the courses table until he finishes. Nobody else can do anything.
Everyone is locked out of the entire table, but all that gets rolled back is my previous query / transaction. Is that right?
That's right. Yes, you're only rolling back the stuff since when you said begin transaction. So normally SQL servers, the database is trying to manage multiple users running queries, kind of overlapping in parallel, trying to do a lot of throughput. But when you do something that modifies the database and update and delete and insert, it has to be a little bit more careful that the results that people see look reasonable. And then if you just run a single delete, that happens fast enough that you don't really notice the fact that you're actually waiting in line when people do deletes. But if you manually run a begin transaction, you're sitting there staring at the screen for 45 seconds, 2 minutes, then people might actually notice that, wait a second, none of my queries are finishing. They're all waiting in line.
And and there's not a utility that I mean, I would assume that there are kind of over for Oracle or MS SQL or the kind of more advanced enterprise databases. There's some kind of administrative overlay that tells people what's happening, that somebody's making a rollback or are people just like sitting there going, what's going on? What's going on? Yeah.
Yeah. No. You can run a command like in Microsoft SQL Server. There's commands you run, and you basically see, hey, my select that I'm running is process 1, 2, 3, 4, and then you can see that process 1, 2, 3, 4 is waiting on process 5, 6, 7, 8, and that's Ted, who has done some kind of delete pending on the courses table. So.
But it's the other users who have to run those queries in order to discover what's actually going on.
That's right. If they have permission, they can run those to see what's happening on the system and figure out who's blocking who. Yeah.
Is that like an admin permission, or is there kind of like a lower level of permission, like some kind of super user? Or
I don't know. It's a fairly straightforward command in that it's like read only, you know. But these days with hackers and computer security, like you generally don't want to just expose information like who are all the users and what commands are they running. And there could hypothetically be sensitive information in the commands. You know what I mean? Like insert into user name equals Ted, you know, social security number equals 1, 2, 3, 4, 5, 6, 7, 8, you know, like that would be kind of
right,
bad
exactly.
If you could just see that. So probably it is locked down so that regular users aren't necessarily allowed to run those commands.
And is that the way that most rollback statements look? If error, you know, not equal to 0, then is that kind of the way that most of them look?
Yeah, because normally you're doing this in some kind of code. We're talking about like doing this as kind of a manual fail-safe where you're manually inspecting things, but normally it's in code. And so it's just saying, I want you to do all these things, and if any error happened, then roll back to some before the interesting updates happened, right? And so that's what it would normally look like in production code.
Right, moving on to cursors then. So just starting off with what is a cursor? Cursor is a database query stored on the server. So it's not a select statement, but it's the results that come out of that select statement and then are stored for you to interact with. So this allows the application to scroll through the rows, basically. And so one of the things they mentioned is different databases have different options with their cursors. So you can do various different things, like you can make a cursor read only. You can control which directional operations are available. So you can only go forward, backward, first, last, etc. And you can also make some columns editable and others uneditable. And then you can also you can have it pull the data in various different ways. So you can have it make a copy, so you're not actually looking at the live data. I don't know if this is the correct way to think of it, but I think of it in like you've got a file and you've got your cursor and you can go next line in the file, you can go home and hit top of the file, you can go end, you can go bottom of the file, and various things like that. That's the way that I kind of think of a cursor interacting with the data that's been extracted. It pulls out something and then you're able to interact with it like a normal cursor in a file.
Yeah, I think that's like a really awesome mental model. And just imagine, Ryan, that these cursors were invented like, I don't know, in the 1960s or something like that. And so imagine that your disks are like really phenomenally slow. Like disks these days are pretty decent, but imagine that in those days your disks were just ancient. And so they're like hundreds, if not thousands of times slower than your disks today. So like, if you were going to do multiple things with 100 rows that you got back from the database, you don't really want to run the query 100 times, each time getting back particular rows, because it's just so slow. So if it's something not that big, you can just hold it, tell the database, hey, would you just hold this in memory for me? And then I can like move around, like you were saying, go to the beginning, go to the end, go to the next line, stuff like that. So it's a very old concept.
Yep. So working with cursors, so one of the things that they pointed out is you have to actually declare it first. So you define what this cursor is going to be, and then after that you can open it. So we'll see examples of that on the next slide. So once you have the cursor open, you do fetch it. So you can do those operations that we were just talking about. You can get the next row, you can go back to the beginning, you can go all the way to the end. And then once you're done with whatever you're doing, you have to close the cursor as well. So just an example of declaring a cursor, you can see up in the top left, it's just saying declare cursor with this name. So in this case, it's customer cursor. And then you say cursor for, and then it's for this statement. So you can put kind of anything there. So in this case, they're doing select star from customers where the customer email is null. So this is declaring the cursor as this statement basically. But just one important thing to note is it hasn't done anything yet here. It hasn't actually run this query. So once you actually do the open command is when it runs this select statement, and then it says basically, here's this data available with this cursor. You're able to interact with it in various different ways. So just know that this declare step is going to be quicker than you might expect, because typically with select statement, you expect to say, oh, it's running a query. It's going to take a few seconds or a long time if it's a lot of data. But the declare statement will be basically instant, and then the open statement will be where it actually runs that query, and then you might have to wait a few seconds and wait for it to actually complete that. So so this is where I start getting into the Oracle, because they only had some Oracle examples here. So this is them actually fetching with the cursor is what this example is showing. So they declare the cursor in a slightly different way. I'm not totally familiar with all of this syntax and the row type stuff, but just understand that this is basically equivalent to this over here, saying declare cust cursor as cursor as a cursor. For this certain statement. So they're basically pulling in the customer table. And then they're also declaring another variable. So you have your cust cursor, you have your cust record, which is just a variable for you to store rows in, basically. And then they're saying, actually begin this operation. And in this case, they're just basically loading the first row of the data, and then they're putting it into this cust record variable that they just defined up here. So they're just pulling the first row of data, they're putting it in this cust record, and then they're closing it, and they're ending this. So this isn't actually doing anything, it's just loading the data, pulling out the first row, and then putting it into a variable. But they kind of left out what you might want to do with that individual row, but you can kind of fill in the blank of, now you have your individual row of data, what do you want to do with it? You can do any series of commands that you might want operating on that individual row. And so this top one was just pulling the first row, adding it or putting it into this variable. This next example is virtually the same thing, except for what it's doing is it's adding this looping element. So in here, we're just pulling the first row. In this one, we're doing a loop over everything that was returned by that cursor. So you got returned, I don't know, 500 rows, and it's going to loop through all of them until it hits this condition. So it exits when the cursor can't find any more rows, basically. And then it ends, and then it will close out the cursor. Again, so they kind of just put the ellipses here saying, so you're looping over this data. We're not doing anything with this. We're just storing it into a variable, but you might want to do something with this. So that's what the ellipsis is just kind of put in whatever operation you want in there. So here is here's the Microsoft SQL example that Ian was saying that I skipped over. I added that as well. So in this one, basically similar thing. They're declaring a bunch of variables here. So they're saying cust ID has 10 length characters, and just same thing for all of these, a bunch of different variables. And then they're opening the cust cursor. This is the part that I don't like, is that they kind of like, they jumped between the Oracle and the Microsoft, and then they don't show where the cust cursor is actually declared. There are certain things that's kind of just left behind. But then this is showing what it looks like in MS SQL. So they're fetching from the cust cursor, and they're storing all of its values into these variables. And so what this is doing, this first step, is just pulling the first row. That's all it's doing. It's just pulling in the first row, and it's saying that first row, all of its values are going to be assigned to these various different variables. So it's going to put it into cust ID, cust name, cust address, and then with that, you can do whatever you want. They left the ellipses there for, you can do anything with this first row that you want. And then after that, they showed that you can do the same thing that we did with the Oracle one, where you iterate through all of the options. So you say while at fetch status equals 0. So basically just saying I'm going to keep fetching until it's done. It's going to keep fetching the next row out of that cursor. So you've got your 500 rows in the cursor, and then you're kind of going through, and you're just every row you're assigning it to these variables, and then you can do whatever you want with all of these variables that you just plug some data in as you loop over everything. And then after that, you close your cursor, and then whatever you've done is done. So that's all I have for cursors. Any questions there?
I do have a question. What did you say again that the fetch status equals 0 means?
My understanding of this is it's basically checking while fetch status equals 0. I assume that basically means while it's able to fetch. So once it gets to the end, it probably changes this fetch status to 1 or something like that. Something else saying that it's done.
Yeah, there are two non-zero fetch statuses. One is you've gotten to the very end and there's no more rows, so that would be a non-zero. And then the other is some error happened and the fetch failed. So so 0 just means that like we're just chugging along one row at a time and everything's fine, and we haven't gotten to the end yet. All right, thanks, Ryan. So so I've been mentioning throughout this series that when you think about writing SQL queries, you have to think about, you're telling the database, I want this set of rows and columns, and I'm going to tell you the characteristics of what I want, okay? But I'm not going to tell you exactly how to do it, and it's your job to figure out how to do it and return that to me, okay? And unless you say like an order by explicitly, the results are just coming back to you however they're coming back to you, because it's just thinking of it as a set, a collection of rows, okay? And the reality is, even when you have an order by, it's still doing it just as a rando collection of rows, and then as a last step, it just sorts them because you said you wanted to see it a certain way, but it's not actually pulling the data back in a sorted fashion. It just gets it all, and then it says, okay, you said you wanted to see it sorted, so I'm just gonna like sort it for you so it looks in that order. Cursors are the one place where you get to explicitly do things iteratively, and it's no longer treated as a set. So I think the example I gave a couple weeks ago is if you had a table and it listed like records, right? So who had the fastest time in the whatever in the marathon, and who had the second fastest time, and the third fastest, and fourth, and you wanted to know how much faster was the first guy than the second guy. How much faster was the second guy than the third guy? So if you want to just calculate how much did each person beat the person right behind them, okay? If you want to know just first and second, I can write a query for you that sort of does that. Wouldn't be easy with what we've learned so far, but it would be doable. With this cursor, you can imagine that if you loop through the rows, if you order them in the order that they finished, right? And you have sort of like the last person and what their time is, and then you save that in a variable somewhere. We haven't really talked about variables, but you can do that. You can just save the number in a variable. Then when you fetch the next one and you see what their time is, you can just subtract the time that you fetched with the variable that you saved for the person behind them, and you say, oh, I beat them by 5 seconds, and then you can actually do something. You can store that 5 seconds somewhere. And so then by doing this, fetching one row at a time, going through the whole table, you can calculate for every single person how much they beat the person behind them by. Okay.
And that actually sounds rather Python-like. So in other words, you do the fetch on the data, you store it in the variable, and then you do, and once you've changed the variable, you have to save it as a particular iteration of a variable, or?
Well, I'm just saying if you fetch into the variable X, by the time you get to the next row, X will have been overridden. So you better save it into a variable called last rows X or something like that.
Right. So you just keep on saving the variable, then you run the query again, and you end up with a complete list of everybody in the time that they finished in the marathon or whatever it is.
Yes. So if you read a little bit about cursors, you will see a lot of places where people say, don't use cursors if you can, because you can imagine that iterating through 1,000 rows is a lot slower than when the database kind of does its set thing and can go whomp in one big fell swoop and do things internally, right? So what we will see, which Ian has previewed in the chat, is that there has been pressure to add more and more functionality to database systems. And so there are certain features, certain functions, but the really big thing is window functions. And so that's why I've actually added a extra session where we're going to talk about in December, we're going to talk about window function. So with this new advanced functionality, I'm just going to make a guess. You probably don't ever need cursors. Okay. You used to need them because you didn't have an alternative, but it turns out that Ian's exactly right. There are window functions that would allow you to calculate the time difference between each person and the person behind them in very few lines of code, very easily. And so that code will run so much faster than a cursor, where you're doing it like a very Python-esque, manual thing. And I'll even say, even in Python, if there is some built-in pandas NumPy function that will do a vector operation and kind of do things in one fell swoop instead of one row at a time, that will be a lot faster than if you loop through and do it one row at a time. So it's always the case that if you can kind of do it collectively, it's
you do it on the entire array rather than just on iterating down one record yeah,
Yeah.
sequentially, which is, I mean, if it's a small amount of data, it's trivial with today's, but if it's a large amount of data, then you can talk about really slow processing.
100 rows, doesn't matter if you do it inefficiently, you're okay. A
Right,
million rows,
right.
you don't really want to be looping through them.
Right.
I can't remember when, but there was some time when like I ran some update and didn't realize, but the update was wrong, and it like all of the values were like assigned off by one row. It was horrible. And so I basically had to do this thing like find the row that's like one below and like copy that value up, and and this was before we had window functions.
The repair
So-
was the repair operation was non-trivial and painful.
Yes, and I had already run it. It was committed. It was the only copy. There was no undo. There was no nothing. So something like this cursor is the only way you can really fix that, because again, if you're just thinking of it as a set and there's no ordering, then you just can't do this next row shift by one kind of a thing or whatever. But nowadays you can. So we'll talk about. There's a number of functions that allow you to do very cool things. So yes, so the additional topics, it's going to be temporary tables in the next session, and then window functions, which is a fairly meaty topic because there's a number of different functions. And then one thing I'm just going to throw in that'll be a real quickie is case expressions. So if you used case statements in any other language, it's just like an if that has multiple branches. Okay. SQL Server, again, the big systems, I think pretty much every system supports them. The only thing to know is that in SQL Server, well, we'll get to it, but since I started, case isn't used as a control flow command. It's just used as an expression. So it returns a value. So you case, this, that, whatever, it returns a value. And so, you can do things like case age, age less than 18, then return this value. Between, 18 and 30, return this value. Between 30 and 40, return this value, whatever. You can do things like that. I only brought it up because I was starting to look at these sample problems, and they would say sort of like, oh, and if you see blah de blah, then return red, and if else if you see blah de blah, return blue. And it's like, oh well, you kind of need to know that this case thing exists. It's not really fancy, but just need it. So those are the additional topics. If there's anything else, you can ping me, email me, message me on Slack, message me on Meetup if there's other topics. But right now, that's the only stuff that I've seen that I feel like you guys really are going to run into these in interviews, in practice tests, whatever, that you kind of need this in order to, pass these SQL tests.
Somebody in chat just asked about triggers, which I think is a good.
I can't remember if that's in the next session, or if we already talked about them. But again, to me, that's not a database topic. But triggers are a way that typically they're written by administrators, and they can set it up so that, say, for example, if somebody inserts a row into this table, I'm going to run this SQL query. All right, so briefly, I know some of you may need to go if you only planned an hour. Last time, I just put in the chat, last time I talked about this problem. So in the book, we have this idea of customers, orders, order items, right? So imagine using the orders and order items tables that we've got in the book. I want to write a query that returns the orders that did not have a particular product. I just picked this RGAN01 thing because it was mentioned in the book, but it could be anything, right? So an order might have 3 things on it. And if one of those 3 things was RGAN01, then I am not interested in this order. I'm only interested in the orders that did not have RGAN as any of the items. So I just want to say that if you just do a simple join between orders and order items and say where order item does not equal argan 01, you're not going to get the correct answers because you're going to get all the other items for orders where argan was one of the items. It will never list argan, but it'll list still all the orders that included that item on one of the other things that was bought. So anybody either had a chance to think about it or thinking about it right now, want to kind of just talk about like how you would go about writing writing a query to do this?
Yeah, I'm gonna put what I came up with in the comments, but I wasn't sure what it was you were asking, so this is kind of what I came up with, and I think it's probably just going to be a subquery to whatever the actual correct answer was. But anyway, that was what I just pieced together.
Okay, so let me see. I should have a query set up, but I don't. So I'm just going to, I don't know what I'm going to do. I'm just going to open up a silly notepad window.
So I didn't do a join, which I think ultimately was what you were looking for.
All right. All right, so this is, can I make this bigger? All right, so this is what you have, Harold, okay? Yeah, and so this is going to return, we have a star here, so it's going to return all the columns. And this will be all the order items where the product is not this, okay? And so this will include items that were on the same order. So if I ordered 3 things, I ordered an X, a Y, and an argan, then the X and the Y are going to be returned in this query. So this is the problem. This is what makes this query tricky, okay? If I said to you, return all the orders that included argan, it would be a really easy query. You just join and then voila, you're done, okay? But because of this one-to-many relationship, it gets a little bit trickier trying to figure this out. So thanks for getting us started. Anybody have a suggestion, either something different or a way to tweak what we've done here? All right, so I'm going to say, I don't even remember what the column is called, but let's just say it's order ID. I don't know if that's exactly the name of the column. All right, so let me change this to equals instead of not equals. All right, so this is going to give us all of the orders where we did have an argan, okay? So the not equals doesn't give us all the ones that didn't. This is going to give us too much. This is also going to give us orders where we ordered multiple things and one of them wasn't. The only thing that will be excluded from this query as it stands would be an order that has a single item that was argan 01. Okay, that will get excluded. But anything where I ordered an X, Y, and an argan, then the X and the Y are going to also appear in here. Okay, but if I do equals, assuming that you can only order argan once because you would have just a count, you know, instead of having multiple rows, then now this is going to give me uniquely the orders that included it. So if this were, just like you said, Harold, if this were a subquery, All right. Then what might I do with my outer query to utilize this special list of all the orders I don't want? Right. So I can say something like where order ID not in this subquery. All right, and then I don't know exactly what it want, but maybe we just say select star from orders O. So I think this query will work. This will return all the orders that don't have an argan, regardless of how many rows and whether there was other things other than argan.
You don't
Any
need
questions?
to join the two tables.
We actually don't, because this select is going to return multiple rows of order IDs, and it's exactly the ones we don't want.
And that order ID is in both tables, so you're using that to select from the other.
Yes, if we
Or
were
not to
joining the two
select.
tables, we would be joining on o.orderID equals oi.orderID. Yep. Any other questions?
I was curious, I don't remember if I've checked this. If this version is faster or more efficient than, say, using not exists, because there's a couple different ways to say accomplish the same thing between the joining, not exists, or using like you have here.
Yeah, the book hasn't mentioned not exists. I've seen some things that a good database might be able to run it slightly faster if instead of using not in, you use not exist. Okay. We haven't talked about it, but basically, when we say not in, the database is told explicitly, hey, give me this list of order IDs, and it has to allocate memory and store them and do whatever. And if you do not exist, it might actually do the same thing, but it might actually find a slightly clever way where maybe it doesn't need to store the ID. It can store something else that it finds more convenient. So, not sure, but I mean, well, we've already learned what I think is a reasonable way to quiz people isn't necessarily what people actually out there do in terms of SQL tests, but I would certainly say that this is a very reasonable answer. It may not be the absolute fastest possible query, but it is a very reasonable query. All right, I had one other thing. So same tables, slightly different concept. Okay, so this is practicing your group buys. So how many people have placed at least 2 orders where those orders had at least 3 items each? And by the way, I don't know if the sample data in the book is too small, but you can change these numbers to, whatever. But the idea is you have some number of orders, but each of these orders has to have at least 3 items. So if Bob has placed 100 orders, but each of these orders only had 1 or 2 items, then Bob does not meet the criteria for this query. Okay, it's not about how many total orders. It's how many big orders, where I've defined a big order as 3 items or more. So I'll post this also on Slack, but I think this is pretty doable with, again, the things that we've talked about, but this is non-trivial. You're not just going to do one join and be done. All right, so I think we'll end the formal part here. We can stop the recording